Is that okay? Plus plus that. So what's going to happen? How do we know what the where the first arrow is coming from? If we already established over here that this carbon down here is in the resonance form has a negative charge, that's the carbon that's going to attack. Is that right?
Mm-hmm.
And it's attacking this carbon because we already said that that carbon has a positive charge in the resonance form. Yes or
Right.
no?
Right.
And so that's going to be the main mode of attack. So that's coming here. This is coming here. And then that's coming there. Yes or no?
Mm-hmm.
And that's going to give me this product right here. Are you following?
Yeah.
Yes.
All right. So this is the major product because the charges match, right? You see how when we did the resonance form over here, how the negative charge is on that carbon, and then this is the carbon that attacks first. And then over here, the positive charge is on this carbon, and that's the carbon that gets attacked first. I take that as a light bulb just came on for somebody. Yes? No?
Yeah.
All right. Where do you think we get the other product from? Look at the location of the aldehyde. Where do you think that came from?
Mm.
It
Right.
attacking the other side.
Okay, I'm with you. So you're saying, let's say, and just disregard this for right now. I'm just using this space down here.
Okay.
All right. So you're saying that it did this. So this is still OCH3. And then now my aldehyde looks like this, right?
Mm-hmm.
Is that what you're saying?
Yeah.
That's correct. That's absolutely correct. Now, why do you think that's minor, based on what we already know about the resonance form?
But isn't it because that's technically like behind, so you have to go around the bone or
Well,
fake?
let's think in terms of what we just talked about. Remember over here, we said that these two, this happened because the charges matched up. Is that right?
Mm-hmm.
Like we know that this is going in resonance, the charge here was negative and then the charge here was positive. Is that right?
Mm-hmm.
So we know that those charges match. Do they match over here?
Okay. No, they don't have over
They
there.
don't match, right? This is the negative part and then this is the positive part.
Mm-hmm.
So the reaction will still happen because it's still a diene and a dienophile, but because the charges don't match, that's why this is the minor product.
So because charges don't match.
Yeah, that's your minor product. Right. This only happens when you put donors and acceptors on your substrates.
Okay.
Any questions about that? I know that was a hard example, but it's good to get the hard stuff out of the way first, right? Because and it gives us a chance to introduce some other concepts too. Let's do something. Let's do that. We can do the next one actually. Take that off for there. Does everybody have this written that's going to write it?
Yes.
All right. I'm going to erase this part. All right. Let's do the next example. It says,
Dr. Russell, this is going to be put on Blackboard today, right?
yeah. I'm gonna
Okay.
chop it up and I'll chop it up and upload it.
Okay.
Yeah. It says,
Mm-hmm.
what is the structure of the product formed when A is heated in the presence of maleic acid, and explain why only one product is formed, even though A has 4 double bonds. How can we explain that before we even get to the product? Right. let's go pi bond by
Only one of them is conjugated.
well, you got two that's conjugated, but you're right. You're on the right track. These two are not conjugated. Is that right?
Yeah.
Yeah.
So we can rule those out. Those are not going to react in a 4+2. Are you following? So
Mhm.
those are out. And then what's the problem here? Is that conjugated?
Yes, but it's trans.
It's S trans. Can I ever get that to be S cis?
No,
Yeah.
sir.
No.
I can't. It's locked, right? So this conjugated system is locked, right? It's locked in an S trans conformation, and I can't do anything. There's no free rotation to get it to go S cis, right? So this part over here is not conjugated, right? And then this part over here, those two alkenes are locked in S trans. Let me put that in there too. Right. So the only alkenes that's actually available to react in a 4+2 would be this system right here. Is that right?
Mm-hmm.
Yes or no?
So A would be considered not conjugated.
Which one? The one in orange that I just highlighted?
The one in
On the
wait.
back side. You talking about back here?
Yeah.
Yeah, because what's the definition that we have for conjugation? The layman's definition. It's alternating double and single bonds, right? Or
Right.
sigma and pi bonds.
Right.
So this is a double bond, and then this is sigma, and then here's your other pi bond.
Okay.
Yeah, so it's not alternating. All right, so the only diene that's available to react is this one. That's highlighted in orange. So let's see what we get from that. And I think, Kamaria, I think your point is about to be illustrated here. I think. Right. Oh, is this going to have a bridge?
Yes.
It is, right? Because one of my substrates is cyclic, and the other one is not cyclic. Are you following that? So it's gonna be that plus this. I'm gonna abbreviate these acids. All right. What are the arrows gonna look like for that? I know it's weird. Right? Is this gonna attack here? Is that right? And let's number them, because see, this is a weird one because it's kind of drawn backwards. So that's 1, 2, 3, 4. And then we're gonna say that this is actually, let's keep the same system we had, because I think we always put 1 on the bottom. 1, 2, 3, 4, and then this will be 5 and 6. Is that right?
Yes.
Mm-hmm. So I'm gonna draw that arrow, and then what else has to happen? This is coming here, right? Is that right?
Yeah.
And then this double bond here is gonna get shifted over to here.
Right.
All right. So let's look at what the product is gonna be real ugly. Don't panic. Don't fret. We can figure this out. So this doesn't change. Make sure I drew that right. Yep. That stays the same. Is that right? Yes, no?
Yes.
Yeah, that doesn't change, right? We didn't touch that. And then the other 6-membered ring, we touched it, but we didn't break it. We didn't break any bonds. We just gonna shift this pi bond to right here. Is that right? Yeah.
Yeah.
And then, so now I got a bond. This is gonna be real ugly. but don't panic. Now I got a bond between, and this is 1, 2, 3, and then 4. I got a bond between 4 and 6. Is that right? And I got a bond between 1 and 2. Yes or no?
Why is chemistry like this?
I don't know, man. Don't blame me. I'm just a messenger. Is that right though?
Yeah.
Yeah. So that's 1, 2, 3, 4, and this is 5, and that's 6. Is that right?
That's the bridge between.
You see the bridge? The bridge is right here, isn't it?
Oh. Well,
And it
yeah.
just so happens to be 2 carbons instead of 1 carbon. But it's still a bridge. And then we got to remember one other thing about the acids. Are they cis or trans?
Her sis.
They're cis. So I got to put them back in as cis. Yes or no?
Yes.
Yeah.
Yes.
The 5 and 6 switched.
Say that again.
Why aren't the 5 and 6 switched? Like I thought it, like 6 was at the top and 5 was at the bottom.
Oh, my bad. They're not switched.
Oh, okay.
I just put them in wrong. That's it now, right?
Yeah.
Mm-hmm. All right. Any questions about that? Go ahead.
Yes, why is the double bond on the bridge and not between?
Because it just so happened that the bridge. Let me zoom in over here. I'm gonna erase all these arrows and stuff too. Uh-oh. I didn't mean to do that. I just meant to erase the arrows. It just so happens that the bridge is a part of my diene, right? Are you following that?
Mhm.
And then and so the bridge is going to be right here. It's going to come from these 2 carbons right here. But it just so happens that those 2 carbons are also bonded to the other 2 carbons in the diene. So when they react, right, the mechanism doesn't change, right? So your double bond in the product, sorry about that. Your double bond in the product is going to end up being here, right?
Mhm.
But it also happens that these 2 carbons are going to make bonds with these carbons over here. So the bridge is just a consequence of where your alkenes were in your start material.
Okay.
Yeah. All right. Any other questions?